Hello. Now, we're going to do our first lab with the new take-home trainers, all right? I'm in my garage, and the print we're using is this one here, all right? Now, on the print, this is a ladder diagram. I'll talk about this and explain it to you in a Teams meeting. But by the time you try to wire this up, you will have already seen the Teams meeting. And we count these ladders. This is a ladder diagram. This vertical line and this vertical line are the rails. And that's where your power comes from. This here happens to be 24 volts DC. That's what we have here. And between the orange jumpers here, that's your plus 24, that's your minus 24. And that's what these two vertical rails signify. Now, the horizontal lines are ladders. It looks just like a ladder, right? So if you know this is your power, then your power in a parallel circuit is, the voltage is the same. So the voltage across here in the first rung is the voltage across your second rung, is the voltage across your third rung, fourth rung, fifth rung. From here to here, the voltage is always the same. Whether it's 24, 48, 120 volts, or whatever. DC or AC, it doesn't matter. Your rungs are where you get your power from, okay? So we count this, 1, 2, 3, 4, 5. We've got 6 rungs. Now, the way I'm showing you to wire this trainer is not the way you want to wire a panel, okay? Big difference. In a panel, most of your connections are only good for 2 or 3 wires to be put under a lug. It depends on what your cut sheet or your factory sheet says that lug will take, or that wire connection under that screw terminal. The maximum that the factory says is tested for is the maximum that you can use under that terminal. So here though, I know these terminals are good for number 12 wire. So if I take 6 of these number 18s, it's less than a number 12 wire. So if we look at this power rail, 1, 2, 3, 4, 5, 6. We've got 6 connections. Now, I'm going to strip this. I'm going to show you how to use strippers, okay? What you want to do, you don't want to cut strands. You want to push and then use your thumb, and see how easy that came off? Now, let me show you again. You want to put it in the right hole, barely squeeze. You can feel it cut the outside. And see, there you go. That's 2, all right? Now, we're cutting right at 3/4 of an inch. I know you're laughing at me, but that's okay too. You see me on the job, I'm doing this too, okay? All right. Now, we've got 1, 2, 3, 4, 5, and I dropped 1, okay? 6, okay? Now, this is our first time. So I'm doing this a bit differently. We use a process that we're going to go back and catch up on that's called daisy chaining, okay? This is not daisy chaining. When you're wiring panels for real, you're daisy chaining. This here, if you see, I've got 6 of them, and I've got them all twisted together, okay? Now I'm going to go on the positive side because here we're making these connections, okay? Right here. 1, 2, 3, 4, 5, 6. Now I know the positive side is looking at the back of the panel, the left terminal strips with the orange jumpers. So I'm putting this one twisted 6 wires into the left side orange terminal strips, okay? So, here, I'm putting that in there, I'm pushing that in there, I'm opening it up. Now, you put it in there and you tug on it, okay? That won't come out, So now, what we've got 6 connections to the positive side of the terminal strip, okay? It doesn't matter which one you take, all right? Cutting them all off, getting them all the same length. I'm gonna pick one because that's our positive 24. So if I look at this strip, I'm gonna cut off about 1/4 inch of insulation. I'm stripping off 1/4 inch insulation. And if you look at this says go to push button 1. So if I look up here at push button 1, and if I look here, it says a normally open contact block. So if I look up here on button 1, normally open. Now, this here is really important. The more I can make this print agree with the real world, the easier my life is, the easier your life is. If it's on the left here, if I can make it on the left here, I'll do it. If it's on the left here and it's top and bottom, the left here means the top here. So if I know every time I come over to a switch, if it's on the left, and it's either going to be on the left or the top here, my eye instantly goes to where the wire should be, okay? Now, there's no rule for that. You don't have to do it like that, but it makes sense, you know? We read pages left to right, top to bottom. If you take your print, when you wire a panel and wire it like that, and I've wired tons of panels. I wired crane panels, I've wired water treatment panels, I've wired machine panels. There are certain things that makes life easier for us. This is one of them. On the left here, button 1, push button 1, okay? It's top bottom. So I know I'm gonna take power to the top, period, okay? Now we're gonna get into wire numbering later, but right now, this is what we're doing. So, I'm going to find a wire, and I'm going to look up here. I'm going to make sure that I get that wire in there, okay? And I'm tightening and tugging, tugging. If you tug on it, it's awfully easy. If you don't tug on it, if you just tighten it up, it's awfully easy to get the wire behind that little square piece that tightens up on it. But if you tug on it and find your problem then, it's a whole lot easier than using an ohm meter, okay? Because it's physical. So I tugged on it. Now that connection is a good connection, all right? So that's the green push button. If we look here, the green push button goes to the green light. Now, I need another wire to go on the other side of that normally open contact to the green push button. This is a series circuit. There ain't nothing any easier than a series circuit, okay? If you can hook a series circuit up, then you got it made, okay? We'll get to parallel later. But right now, we got to go from the other side, that's this side of the normally open contact, to the green push button. So let's do that, okay? So I've got this wire, pull me one out. Now, on stripping wire, it's real easy. You want about 1/4 inch of wire, okay? Right there, 1/4 inch of wire. You want to put it in the right hole in your strippers. Get a set of strippers like this. Don't buy cheap strippers. Now, I can feel whenever I barely squeeze on it, I can feel it cut through that insulation. We spend our lives taking care of insulation. If we don't, if we screw the insulation up, we've got junk copper. That's all we got. We don't have good wire anymore. Okay, what makes good wire is the copper or aluminum and the insulation. So I felt it cut through the outside. Now watch me, I'm gonna push with my thumb. Okay, well, I'm talking and trying to do it. Watch this, there you go. Push with your thumb. Cut with this hand, then barely let it ride. Just like your hand on a throttle on a motorcycle or a four-wheeler. You know, when you first start riding a four-wheeler, you got a death grip on that doggone throttle. Death grip. But 2 weeks later, you just got your hand laying on it, you know, okay? So let's cut that off. Let's do it again, okay? So once I squeezed that, I felt it cut. Now I'm shoving with my finger, with my thumb, and now it's a good stripped wire. If you see somebody sawing on insulation like that, you're cutting copper. You're not professionally stripping the wire, okay? So if you have trouble with that, you're probably squeezing too hard with this hand. Okay, I'm gonna cut this off and do it one more time. Let you see it, all right? Now, I'm gonna put this in here. It's in the right hole. I squeeze it. I can feel it cut the outside. Now, this hand here is just barely riding on the strippers. This thumb, push it off. Look there. Okay? It's easy. You don't have to saw it. If you're sawing it, you're not an electrician. I'm telling you, you're just not. So, we got this cut. Now, we're going to go to the other side here of the green push button. All right? So, here, I'm showing you everything to do. Now, I'm going to back this screw off here a little bit. Go put that up in there. Now, I've got it twisted. And if some of the strands start poking out, come off of it, twist it again. Get all the strands under there. You have to have all the strands under every connection. Okay? So. Okay, I'm tightening it up. Now, they're not lug nuts on an F350, okay? Tighten and tug, tighten and tug. It didn't come off. It's a good connection, okay? Now, we made this connection, okay? We made this connection. Now we got to take that wire from here to the green light, okay? So, again, we're going to strip this wire right. We're going to put it in the right hole, squeeze it. I felt it. You know, you got to get a good feel for it, like playing pool, playing golf, fishing, anything like that. I felt it cut through the insulation. Now, watch my thumb. There you go. That's all it takes. You don't have to saw it, okay? So, I'm going to twist it. Your wire has a natural twist. So I'm going to look at it. Whichever way it's twisted from the factory, I'm going to take it farther. I want a good twist, okay? I want to make it one unit, all those strands, okay? So we got to go to the green light. So I got to look at the front. This is the green light. Now, if it's the left on the print, I'm going to make it the left in the real world. Or if it's the left on the print and if it's top to bottom, left goes to top, right goes to bottom. That makes my world easier. It'll make your world easier. So it's on the left. Here we got the left. So I'm going to back this off here. I got it slid in there. And I'm going to tighten this screw up. Tug, tug. Oops, came out. Oops, came out. Okay, so now I got to do it again. But you know what? It's easier to find now than later. So I'm twisting the wire up again, getting a nice tight twist. And we'll put it in there. Well, if I can hold my screwdriver, I'm going to put it in there. Back it out again. Got a good tight twist to it. Put it up in there. Tighten and twist, or tighten and tug. It's good connection, see? Okay. Now, we're going to take one more. And it's a series circuit. We have hooked up from here to here. Then on the other side of the green, push button to the light. Now we're going to hook to the negative side of the light to the negative rail. Okay? So that's what we're going to do now. Now, here, again, see there how easy that was? Practice stripping wire. If you're going to be a professional, okay? Now, I'm going to hook it into the other side of the light, just like the print says. Just like the print says. Well, that didn't work. I'm going to twist the wire again. And I'm going to back that out a little farther. It didn't have it backed out far enough. Stick that up in there, okay? And I'm tightening it up. If the light tries to turn on you, hold it, okay? Tight tug, okay? It's good connection. Now, we got to go to the negative side of the power supply. The negative side of the power supply is the right orange jumper here. Not here, here. This is positive, this is negative. So, I am going to put this in the negative side. Okay? I didn't have this twisted enough. You want to twist it all the way because you need all the strands for the ampacity. You need all the strands. Okay, tighten, tug. Let go of the screwdriver. Tug it. It's good. Okay? Now, what I'm going to do is I'm going to plug this in, turn it around, and if we, well, let me back up. Okay? We've got to use our meter to test it, okay? So, if we look at my sheet here, I say the green light, I tested it before. If you go hunting, you gotta know what you're hunting. So the green light on my trainer reads 8.9 megohms, 8.9 million ohms, okay? Now, the amber light is infinity, the red light's 51 megohms, the blue light's 2.1 megohms. I don't know why they're different megohms on different colors, but they are. Now, the amber light that is OL, I don't have any answer for you. LED lights have drivers in them. Drivers limit the current. Most drivers, 99% of the time. In fact, this is the first time I've ever had a driver read OL. But the light will burn. I don't know why. But you know what? If we know that, and if we put power on that light and it burns, it is what it is, you know? That's just part of understanding our own meter. understanding how to chase stuff down, okay? Now, right now, I know 8.9 megohms is that green light, all right? So we can take our print, we can take our print wherever it's at, right here, okay? I'm on my knees, I'm in my garage, give me a break, okay? Right here, if we disconnect our plus 24, we've got to isolate this from the power supply, okay? We've got to isolate it. So that means isolating means pull one side off so we know what we're reading. Most of the time when we don't know what to use our meter for, we don't understand the circuit. We don't understand what we need to do. What we need to do is isolate the circuit we're looking at. We've got to isolate this circuit. We've got to disconnect the plus, okay? So I'm going to go over here right now. I'm showing you what you need to do, okay? I just disconnected all the pluses that I put into that power supply. And the reason I did that now, what we're doing is we are putting our ohm meter between here, and we're just reading down. If we don't do that, we're reading back to the power supply. This power supply has about 800,000 ohms on mine. So that 800,000 ohms, the ohm meter is going to read everything. So we've got to disconnect one side. If you're out there in motor controls, you're pulling a fuse. There's a fuse right here in the real world. You're pulling that fuse and getting on the bottom side of the fuse, no problem, okay? But right now, we disconnected our positive side, which has all 6 of these, okay? Now, we're gonna put the plus side of our meter, okay? Now, I'm gonna take our meter. This is my home meter. This is the one I've got in my garage, okay? And I'm gonna put it down here, hopefully you can see it, okay? If you blow it up, you can see it. Now, I'm taking this positive side and I'm wrapping it around because I stripped it long enough to the positive side of my meter. Now, on this print, if we have all open switches, we should read infinity, okay? Can't get through here, 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 can't get through here. That's infinity, okay? So, if you're out there and you're putting your meter between plus and negative, you can take your meter and slide it in that slot with a screwdriver. Good connection, hands-free, you can do stuff, okay? Now, I'm reading infinity, OL, okay? Now, if I push button 1, I should read the green light. Now, this other sheet, the sheet y'all filled out that told you what all the lights read on your trainer. Every trainer is different. It's going to be a little different. Mine says the green light's 8.9 megohms, okay? There's nothing else on here that reads 8.9 megohms. So if I push the green button here, I should read the green light, 8.9 megohms. Let's see if I do. .87 megohms, okay? What's the odds that that's not that green light? I mean, nothing, right? So I'm looking at that green light. So it tells me that this circuit here is correct, all right? Now, I'm gonna stop the video. I'm gonna wire the rest of this up. And then we're gonna come back and check it all and see what we get. And that's what I want you to do. Most people don't know what to do with their meters because they don't know what they're hunting. That's why I had you read all these loads. The loads are the lights, the ohms on the lights, and the ohms on the relay coils. So once you do all that, once you read all that, excuse me, and write it down, then you know what you're hunting and you know what you're looking at with your meter. And that's such a great feeling if you know what your meter's looking at, you know? So many people don't. And I'm giving you the secret to being a top-notch troubleshooter. You gotta know what you're hunting, okay? So, right now, I'm gonna wire the rest of this. I showed you how to wire the first rung. The first rung was right here with the green light and green push button. I'm gonna wire the rest, and I'm gonna come back with another video, step through me checking everything, and then I want you to do the same, okay? So, take care. You can do it. I'm here for you. Email me with any questions. I'll talk to you soon.